My presentation mainly focused on the next trends in healthcare and medical practices. In fact, when we observe the trends, the technology trends, we observe many things. We all know from our own experience that when we deal with doctors and practitioners, basically health matters when we go to the doctor's office, and the information about our health is contained in document. But in fact, we all have had the experience that we go to one doctor, then we do some analysis, then we go back to the doctor and we need to redo the analysis. There is no continuity in the healthcare systems today. So my talk mainly focused on what we believe is the next paradigm, next generation paradigm, which we called virtual twins of healthcare. And those are focusing on the patient itself, organs, body, on the hospitals, because we can consider the hospital as a system itself, and also at the national level on economical and medical model to conduct a health policy, if you will. The trends that we see are catalyzing this transformation. More accurate and precise information, extremely diverse kind of information, from PET scan, MRI, ultrasound imaging, all the kinds of data that we observe today. And medicine today is not siloed in one specific data. Now medicine needs to have a 360 holistic understanding of all those data at once and their evolution. So this calls for a more integrative paradigm that we call virtual twins. And so we presented our investment in that space. We were the leaders in twins in adjacent industries, manufacturing industries, boat, car, planes, cities, and we are totally convinced that the next step is going to be the twins of organs, the twins of cells, the twins of the whole body, the twins of even population cohorts. And so I illustrated my talk with a real example already being piloted by practitioners and doctors. Cardiology, so Professor Hoganson in the Boston Children's Hospital is already using a living heart twin for surgery planification and even device personalization for specific cardiology diseases. And we are partnering with FDA to do that. Neurology, we are partnering with our friends in Marseille to do a living brain project, for example, to help for epileptic patients where there is no treatment, there is no drug, and therefore the only solution is surgery. But of course, when you all think in terms of surgery in the brain, this is extremely delicate. So we need to understand what will be the impacts of any surgical intervention. And we use a virtual avatar, a virtual twin of a brain, extremely realistic, when we can simulate and emulate epileptic strikes. And therefore, we can help the practitioner and the surgeon decide exactly what he has to do. Oncology, we also showed how AI and data science approaches can not only help radiologists better identify and understand tumors and evolution of tumors, but also where the next generation of 3D technologies can help them transition, if you will, from a pure 2D imaging approach to a real 3D tumor twin approach, even understanding the evolution of the tumor itself. And finally, and this is something which is a massive transformation for the industry, what we call synthetic control arms, where basically now in clinical trials, you don't need necessarily to have what we call a control arm, you know, the population to which you don't give the candidate compound, but this is almost what I call a placebo arm. You can basically synthesize a virtual cohort, a virtual arm, without the need of enrolling real people. Because you recycle previous data from previous clinical trials, even though they were not done for the new compound, but with mathematical calculus, we can basically generate virtual cohorts. And so all those are examples. We are now building an industrial scalable infrastructure to make those twins available for the practitioners and the professionals, but also for the educational and the next generation workforce of the future. Because the virtual model not only helps one specific patient or one specific practitioner, but it also captures knowledge and know-how of the field, and therefore ease a lot the sharing and let's say the medical culture in the field. And lastly, the last trend that we see is telemedicine and new kind of online medical services. Virtualization, if you push it to the extreme, is not only virtualizing the object, it is virtualizing the engagement, the relationship between practitioners among themselves or practitioners with their patient. And so the ability for us as a company or for us as a country or for us as a scientific community to virtualize knowledge, make it available to an audience, and also from an economical standpoint, exporting that is at stake. And so we overviewed all of that because we believe this is extremely important for the future. So ethics, of course, it's always related to healthcare, and even more so with the emergence of AI and data science. First and foremost, we need to say that we have not waited for AI to look at ethical matters. As you may know, in any clinical trials, there are some steering committee and ethical committees already, really looking at the processes and what is being done. In every of our projects, we have those. But of course, ethical concerns are always related to what do we do with the patient? Do we do what we do for good? Where is the limit? Transhumanism is trying to augment people. Medicine is trying to heal and cure people. So, of course, those topics are extremely important. When it comes to data, we think that there is a wake-up call that data, of course, are belonging to a patient first, but it's also a notion of common good. It's a patrimony at the national level, like frequency in the air, like borders. And so this is something that is not to be taken lightly. It is to be taken at the political level as well, as a national patrimony. And therefore, whenever there is, of course, private or public, positioning in terms of data, there is also this notion of national patrimony that has to be balanced. And it is only with this higher, let's say, global view of individual and national patrimony that I think we will have something meaningful. Now, from the technological standpoint, and we had some talk also on that, there are a lot of new technologies helping us moving that way. In the synthetic control arm that I mentioned, in fact, under the hood, there is a very nice technology that I call Trust, which is basically enable our customer to benefit from clinical trial data without the possibility to identify someone. And how do we do those? Basically, we mix different data from different persons. So we build, if you will, some sort of Frankenstein data, which corresponds to nobody, but still has all the inclusion and exclusion criteria meaningful and relevant for trials. So there are lots of new approaches, technologies, homomorphic encryption, differential privacy that we work on with a dedicated organism to make sure that what we do is always with oversight of not only regulatory bodies, but involved patient and, let's say, a technological differentiation that is guaranteeing from the scientific standpoint that this is a trustable approach.